Welcome back, everyone. So we wrapped up chapter 9 last week. As I mentioned, it was a short chapter, which is why we will be quizzing chapter 9 and 10 together. So today we start chapter 10. Fortunately, 10.1, not a section we have to worry about, but 10.2 and the other sections in chapter 10 will all be dealing with some geometry. And then within the geometry, we'll probably tie in some of the measurement things that we talked about in chapter 9. So for today, 10.2, we're looking at triangles. So I'm hoping everyone knows what a triangle is. That technically, if we were to define one, a triangle is a three-sided polygon. Okay, a three-sided polygon, polygon's just a fancy word for a shape. Now, if there are three sides, that means that your polygon also has three angles. And the three angles in every triangle add up to a certain amount. I don't know when's the last time you worked on any geometry, but the sum of the angles in a triangle is always 180 degrees. And that's something that we're going to have to know moving forward, okay? Now the measures of the angles and sides correspond. And what that means is there's a relationship between the sides and the angles. For instance, if there were three equal angles, then there would be three equal sides, or vice versa. If there were three unequal angles, there would be three unequal sides, or vice versa. If there were two equal sides, there'd have to be two equal angles. So there's a definite correspondence between the measures of the angles and the lengths of the sides. Okay. Now what we're going to do first is just classify triangles, which means we're going to be naming them. And there are two names, like a first name and a last name, that you could give a triangle. So triangles can be classified by the angles within the triangle, and then they can also be classified based on the relationship between the sides. Okay, so every triangle can technically be given two names, but we're going to separate them out for the moment. Okay, so if we were classifying triangles by the angles that were within the triangle, we would say that acute triangles have three acute angles. Now, if it's an acute triangle, if it has three acute angles, that means that the angles that are in the triangle measure between, not 90, they measure between 0 and 90 degrees. So acute angles are angles that measure in between 0 and 90 degrees. If your triangle has three acute angles, it is an acute triangle. And the first triangle that's in the box here would be an example of what an acute triangle might look like. So let's say that this angle here is, 50 degrees. Let's say this one here is 70 degrees. That would be 120, so then we'd have one left over, 60-degree angle there. So this would be an example of an acute triangle. Three acute angles, three angles that are between 0 and 90 degrees, okay? So if you have an acute angle, acute triangle, you have acute angles. If you have obtuse triangles, that means you have an obtuse angle. You have one obtuse angle, and you cannot have more than one obtuse angle because an obtuse angle is one that measures between 90 and 180. And you will not be able to have more than one of those because it would exceed the sum of 180 for a total triangle. So for instance here, we could say that this is an obtuse triangle. Let's say that this angle here is 120 degrees. If there's 180 total, that would be 60 left over. Maybe this one's 35 degrees, and then another 25 degrees here. Okay, so three angles. If you have one that is an obtuse angle, then you have an obtuse triangle. Okay, and these are all three here acute angles. Okay, so you can have an acute triangle, an obtuse triangle. I think the next one is probably the most common. We see this a lot in algebra. Right triangles. And right triangles have one right angle, and a right angle is one that measures exactly 90 degrees. So a right triangle might look like this third one here. This is what a right triangle might look like. Now, we're not allowed to make an assumption about it being a right triangle. What you're going to see is a little box like this in the corner to signify that you have a right or 90-degree angle. So that is a right angle, making this a right triangle. And then that's half of your 180 degrees, so maybe you have a 50-degree angle here and a 40-degree angle here, and there would be 180 altogether. Okay, so you have acute, obtuse, or right. And then lastly, you have what we call an equiangular triangle. If it's equiangular, that means it has 3 equal angles. So 3 equal angles, this would be a picture of what your equiangular triangle might look like. Now, if all those angles are equal, you have 180 degrees total. If you broke that into 3 equal angles, 180 divided by 3 means that each of those angles has to be exactly 60 degrees. So the only way this happens is if you have 60, 60, and 60. Now the other ones I showed you, you know, the 40 and 50, for example, in the right triangle with the 35, 25, 1, those measurements can change. I was just trying to give you examples. But for the equiangular triangle, they must be 60 degrees each. Okay? So these are just examples in here. Numbers could change for these first 3, but for that last one, equiangular has to be 60. All right, so these are names you can give a triangle based on the angles that are in it. Now you can also classify a triangle by its sides. So if we have scalene triangles, a scalene triangle is going to have 3 different sides. Now, if all the side lengths are different, as I mentioned at the beginning, that means all the angles would be different as well. So this might be something that could represent a scalene triangle. Now, if you don't have any measurements on the side lengths, you might see something like this, where you have 3 different markings. Those different markings symbolize those 3 side lengths are different, okay? So a scalene triangle has 3 different side lengths. You can also have what we call an isosceles triangle. And isosceles triangles have 2 equal side lengths. This is kind of a big one. We'll do a lot of solving with isosceles triangles. Remember, if there are 3 different sides, you have 3 different angles. If you have 2 equal sides, that means you have 2 equal angles. So this also means 3 different angles, right? And this one means 2 equal sides, 2 equal angles. Okay, so this is what an isosceles, in lots of ways it could look. Just as an example, an isosceles triangle could look like this one. Now you can't assume that those side lengths are equal. Again, you would see markings like this. If the 2 sides had the same marking, that means that those 2 sides are the same. They're equal. Technically, the geometry word for equal is congruent. So maybe you want to make a note of that somewhere. Let's put that up here. The geometry word for equal is congruent. So if you hear that word, it just means equal. Okay, so here you have an isosceles triangle, 2 equal sides. That means 2 congruent sides. That means it also has 2 congruent angles, and the angles that are congruent are going to be the ones that are at the base of that isosceles triangle. So you have the angle that is in between. That's called the vertex angle. The vertex angle is between the 2 congruent sides, between the equal sides. And then the other 2 angles, different marking because they're not necessarily the same as the one above, but they are congruent to each other. So notice that those markings match. And we are going to call those the base angles. And they're always congruent. Okay, so we have scalene, 3 different side lengths, isosceles, 2 equal side lengths and 2 equal angles. And then you have the last one, maybe you could guess, based on the picture, is equilateral. So equilateral triangles have 3 equal sides, which means you have to have 3 equal angles, and if it's got 3 equal angles, because those angles are all 60 degrees, it's got to be equiangular if it's equilateral. So this is what your equilateral may look like, just like the equiangular, one and the same. So all 3 sides are going to be equal, and then equiangular means all these are going to be congruent equal as well, which means they would have to each be 60 degrees. Okay, so equilateral, equiangular have to coincide there. All right, so that's just some vocab. Now I want to show you the types of problems that you're going to see regarding triangles. So you're going to be asked to do one of two things, either find missing sides or find missing angles. And we're going to start with the angles. So number one says find the measure of the missing angle, and what we said before is that the three angles in a triangle have to add up to 180 degrees. So let's call this missing angle x. Okay, if I add the 82 degrees, the 61 degrees, and then the x degrees, technically those have to make 180 altogether. So 82 and 61, that's 143 degrees. If we want to figure out what our missing angle is, all we have to do is subtract that from the 180. So if we take away the 143 that's already in the triangle, what is left for our angle? So x is going to equal, let's see, 180 minus 143 is what, 37 degrees? Let me not make any mistakes this late at night. Okay, 143, just to double check. All right, good, 37 degrees. So our missing angle is 37 degrees. Okay, not so bad. Now number two looks drastically more complicated than number one, but it's really the same concept. If we have three angles in a triangle, the three angles in a triangle have to make 180 degrees. Just have to do a little bit of algebra on this one. So we take one of the angles, 7x plus 6, we add the other angle, 5x plus 5, we add the third angle, 6x plus 7. And all together those have to make 180 degrees. Now I could put the parentheses in there, but sticking these parentheses here aren't going to change that because there would technically be a 1 in front. So I'm going to leave the parentheses. It's a little easier than to see what we have to do to solve. This is combined like terms, right? I want to add all these x's together. So 7 and 5 makes 12. And then 12 and 6 is going to give me 18 x's. And then I'm going to combine the constants here. So I have 6 and 5, which is 11. 11 and 7 is 18. So 18 x plus 18 has to equal 180. So now we're going to subtract over this 18. Let's cancel that out. And that leaves us 18x equal to 180 minus 18 would be 162. And then to get rid of multiply by 18, we're going to divide both sides by 18. Oops. I wanted to change that to green. Alright, if we divide both sides by 18, I know we haven't really done much in terms of solving equations here. Hopefully you're okay with some of this. We're going to end up with x equal to, let's see, 162. Let's just double check all the math. We subtracted 18 to get 162. So 162 divided by 18 is 9. So x is equal to 9. Alright, so we had x equal to 37 here. Notice that I had a degree symbol because that x represented the measure of that angle. Now here it's x equals 9 without a degree symbol because it doesn't represent the measure of any of these angles. It just represents a value for x. If I had to find the measure of the angle, it's not asked here, but if we did have to find the measure, we'd have to plug that in. So for example here, 7 times, if we plug 9 in plus 6, would be 63 plus 6, so then the angle would be 69 degrees. If we were asked to plug them all in, we could do that, okay? But not asked here, so we solved for x. Moving on. All right, let's see. Number 3, we want to find the measure of angle A. So they're asking us to find this measure here. Now I don't want to stick another x in there because x's are already used in the other two angles. So I have to use what I know. First of all, this is a triangle that has two congruent sides as marked here, which means it's isosceles. Okay, if we have two congruent sides, that means that these two base angles are also going to be congruent. So I know that the 2x plus 12 has to equal the 10x minus 20. All right, if I want to solve this equation, I want to get these like terms together. So I'm going to subtract 2x from both sides to cancel that out. That's going to give me 12 equal to 10 minus 2 is 8x. And now if I want to get x by itself, I'm going to add 20 to both sides. And now I have, whoops, sorry about that. I have 12 and 20, which makes 32, equal to 8x. And then the last step here to solve, if x is being multiplied by 8, we're going to divide both sides by 8. So that cancels, and x is going to be equal to 32 divided by 8 gives me 4. So x is equal to 4. Now in the last one I stopped at x is equal to 9 because it said just solve for x. Now here it doesn't say solve for x, it says find the measure of angle A. So x equals 4 is not going to be my answer here. In fact, I just want to sneak this in there a little if I can. X equals 4. Okay, so what I'm going to have to do is plug that back in. Now if I plug it back in here, 2 times 4 plus 12, or 8 plus 12 tells me that this angle is 20 degrees. Now I could plug it into this one, but I just said that they're going to be equal. So this has got to be 20 degrees as well. And we can just verify that we did our work right? 10 times 4 would be 40, and 40 minus 20 is definitely going to be 20 degrees. So now how do we find the missing angle? Well, the three angles in a triangle have to add up to 180. So I have 20 degrees plus 20 degrees plus the missing angle equal to 180 degrees. So that's 40 down there at the bottom of the triangle. If I just subtract that 40 over, that's going to be gone, and that means that our missing angle is going to be 140 degrees. So obviously that triangle is not drawn to scale. That doesn't look like an obtuse angle up there, but we're going to say angle A, and we can use this little symbol. Angle A is 140 degrees. Okay, lots of algebra here, probably more algebra than we expected to see in this class. So hopefully you're not too rusty on solving, okay? Number 4, I think, is a little more challenging because we're asked to find all of the missing angles, and there are a bunch. If we were just to point out what's missing here, we're missing a third angle here. We got one here, and one here, all missing. And this was intended to be one connected line here and one fluid connected line here. Okay, so if that wasn't obvious in the picture. So let me back up now that I put all that in there. Let's go ahead and label the ones that we're looking for. So let's call this A, let's call this B, and maybe this C, and this D, so we can organize our work. I think A would be the easiest one to start with because I have the two other angles in that triangle. So let's see, 47 degrees plus 90 degrees plus whatever A is going to measure has to make 180. That's one of our triangles. So this is 137 degrees here plus A. If we subtract that 137 degrees over, and then we see that A is going to be 43 degrees. All right, so I got one. We got 43 degrees here. And then B. There's a couple ways I can try to explain this to you, but let me show you one of them first. So we talked about 3 kinds of angles at the beginning of the notes to form different triangles. We said acute angles are between 0 and 90. Obtuse angles are between 90 and 180, and that right angles were exactly 90. Well, a straight angle, I don't know if you've heard of a straight angle, but a straight angle is basically a straight line, measures 180 degrees. So right here, we have a straight line. So we have 180 degrees total. Now if 43, oh sorry, that's not the one I wanted to highlight. We have 180 degrees here. We have a straight line here. And there's actually lots of places, right? This is 180 degrees total. This line is 180 degrees, but I want to focus on this one. This is a straight angle here, 180 degrees on that line. So if I have 43 of the degrees here, then the other, the supplement is what we call that, to the 180 has to be here. So if we took 180 and subtracted the 43, that means that this bigger angle right here has to be 137 degrees. Now I could do that again. Oops, not what I wanted to do. I'll get rid of my highlighter here. I want to then highlight what's going on here. So angle B, we said this one is going to be 137 because it makes a straight line with this angle here. Okay, now this is another straight angle, another 180 degrees. So if this angle is 137, then the rest of it has to complete the 180, which means this angle's got to be the same as A. It's got to be 43 degrees. So that's one approach we could use to look at angle B versus angle A. So this was A, and this is B. Another thing that again, I don't know when the last time you've seen any geometry is, but when we have angles created by two intersecting lines here across from each other, like angles A and B, we call those vertical angles, and vertical angles are always congruent. So we could say A and B are vertical angles, and those are always equal, always congruent. So if A is 43 degrees, B has to be 43 degrees. And then how would we figure out C and D from there? That's a good question. Maybe I intended for C to be. Goodness. I think I made a goof on this problem. I think this one was supposed to be 90 degrees as well. Basically what we have is a mirror image, a reflection of the triangle. So two congruent triangles. So if this one's 90, then our last angle here is going to be congruent to the one we have across here. So it's going to be another 47 degrees on this guy. Okay? I think you're going to see one like that in the homework. I believe I just missed the angle. So these were both supposed to be 90. Okay, so if you want to mark that one on yours, then we'll be good. Okay? All right, so finding angles, that's probably about as bad as it could be, unless you don't like the algebra. The number 3 might have been worse, but let's move on. Let's see, how do we box these in here? That was one of the angles, that was one, and then that was one. All right, we also should be able to find missing sides, and it could involve information based on the triangle. Now, number 5, I see a lot of common mistakes. People want to say, oh, 3 sides of the triangle, they have to make 180, but that's not true for the sides, it's true for the angles. And notice that the 5x plus 34, 12x minus 1, and 3x plus 18 are labeled on the sides, okay? So not anything to do with the angles. I mean, they correspond, but we don't know the measures, all right? So what do we do here? Well, in this particular case, this 3x plus 18 is going to be extra information that's there to throw you off. We don't know the relationship between that side and these two. The only relationship I know is that this side and this side, as labeled in the triangle, are congruent. So I don't want to use this information. I just want to use the two that I know happen to be the same. So we're going to say here, get rid of this ugliness that I've created in my picture, that this is extra info. Okay? That's extra info for now. To solve, we're going to say that the 5, let me not use green, that the 5x plus 34 has to equal 12x minus 1. So we're going to subtract 5x over, although you could have chosen to move the 12. And then we have 34, excuse me, equal to 7x minus 1. And then we're going to get this 1 to the other side. And that gives us 35 on this side, and we still have the 7x. Now we can get rid of multiplication by 7 with division. So we divide, and that gives us x equal to 35 divided by 7 is 5. Now, make sure you're following directions again. If it said solve for x, we'd be good, we'd solve for x, but this one says find the missing sides. So we actually have to plug x in to figure out those side lengths. So here, 3 times 5 plus 18, or 15 plus 18, makes this side 33, whatever the units are. Here, let's see, 5 times 5 plus 34, or 25 plus 34, makes this 59. And then over here, 12 times 5 minus 1, or 60 minus 1 is 59 again. So this side length is 59, this side length is 59, and this side length is 33. All right, there's that guy. Now the last one is going to use something that I don't think we've seen in this class. All my classes are a blur. I know you see it in just about every algebra class that you take. This is a right triangle. And if you know anything about right triangles, or the relationship between the sides of the right triangles, we have a formula called the Pythagorean theorem. And the Pythagorean theorem formula says that a squared plus b squared has to equal c squared, where a and b are the legs. They're the sides that make the right angle, and then C is the hypotenuse. It's the longest side. It's the one that's opposite of the 90-degree angle. So in this triangle, this would be C. And then the legs are interchangeable. So I could say A is 9 and B is 12, or vice versa. I could have put B over here and A over here. But what we want to find is the missing side here, which is C. So instead of A squared plus B squared equals C squared, we're going to say 9 squared plus 12 squared equals C squared. And let's see, 9 squared is 81, 12 squared is 144, and then if I add 81 and 144, I get 225 equal to C squared. Now, again, solving some algebra here that you probably haven't seen in a while. Over here in this equation, right, the opposite of -1 is +1, or the opposite of times 7 is divide 7. So what is the opposite here? Come on, paper. Over here I have C squared equal to 225. If I want to solve for C, what is the opposite of squaring something? It is taking the square root. So I square root both sides, which means C has to equal. Go to my calculator. I know this one, but just so you can see it, you're putting in the square root of 225, and it's 15. So this missing side has to be 15, right? And if you wanted to verify it, just go back to your 9 squared plus 12 squared. Does it equal 15 squared? Well, 81 and 144 does in fact equal 225. Okay, so you could use that to check. All right, so I know it's a lot more algebra than we're used to seeing. I don't think it will be algebra heavy when you get to your assignment, but if you need any help, by all means, send me an email. All right, have a good one.